All right, so this topic deals with prefixes and homogeneity. We will look at prefixes briefly, but we're going to focus on homogeneity, how to solve the questions, and what to expect from the examiner in terms of questions. The first topic, in terms of recalling the base units, we understand how that goes about. We understand how to express the derived units from the base units. Well, that is exactly same from O-levels and IGCSE. We are going to do topic number 4 first, and then we're going to follow towards topic number 3, that is homogeneity. The first one is we need to remember this table, which is for prefixes. So tera is 10 raised to power 12, giga is 9, mega is 6, kilo is 3. Now, one confusion that you sometimes see over here is that the capital K is for Kelvin, that's the unit of temperature. And centi is -2, and so on and so forth. We need to memorize the whole table, right? Now, you will see these values, for example, representing other values. For example, let's say that we have the mass of Earth, which is 5. For example, it's 6 into 10 raised to power 24 kgs, right? Or 5.98 sometimes. But these prefixes, or you can say these standard notation, standard forms, must be familiar with them, because examiner is going to be using them very commonly. So for example, if he says that the radius of an atom is 15 picometers, then we have to go back to the table and realize that pico is -15. So I'm supposed to write down 15 into 10 raised to power -12 meters on my calculator to use this in a calculation. Similarly, let's say if it says that the mass of an atom, let's say, is 9.5 nanograms, then definitely we should be able to replace nano as 10 raised to power -9. Notice that the unit is not changing. Meter stays meter, but the prefix pico is being opened up as its power or relative magnitude. So this one looks like 9.5 into 10 raised to power -9 grams, right? Now let's see how to do that on the calculator. Similarly, if you were to use the calculator for this purpose, then putting in the values would go something like this. So 9.5 x 10x button with -9 power, again, gives you that 9.5 nanograms or nanokilometers or nanometers, whatever the prefix may be. So you can use this x 10x button for that. I will also attach a link in this video in the description where I've explained this use of calculator extensively with the other methods or other tricks and tips of the calculator that will be helpful for you in P3 and P5. And let's say that you want to convert this -9 into something else in the prefix table. So you press this ng button and then you press it again, you realize it's converted into -12, which is pico. Press it again, it converts into -15, which is going to be atto. Now, atto is not a part of your course. Then if you want to go back, then press shift eng, and you see that it's going to go back up the prefix table, which has powers of -12, -9, -6, so on and so forth, right? So play with this eng button and see what it does for you. Shift eng and eng button. It is equally acceptable for large powers. For example, if I was to deal with, let's say, 5,000, so I can write down 5 x 10 x 3 as 5,000, which is 5 kilo, right? If I were to write down 5 into 10 raised to power 6, then I can use 5 x 10x button into 6. This is going to give me 5 with 6 zeros, right? And similarly, I can use the eng button to quickly convert it back to its representation, which was given in the question for the sake of example, right? So again, the eng button is acceptable for the powers in negative of 10 and then powers of positive in 10. And you can use the x and x button to write down both powers, right? Okay, let's go back to the video. So let's move on to the next topic, that is homogeneity. All right. So homogeneity deals with the fact that the units on the left-hand side must be equal to the units on the right-hand side. Now, this particular tool is used by engineers and scientists to make sure that the equation that they're presenting, the equation that they're projecting, is exactly the same on both sides of the equation. For example, let's look at a model equation that is V equals to U plus AT, right? Now, we can see that on the left-hand side, we have the variable of velocity. Now, for the sake of discussion, I'm not referring to this as initial or final velocity, but velocity itself. U is generally referred as the initial velocity, but over here, again, we are only interested in the units, so I'm going to represent that as velocity. A is self-explanatory. You may see that this looks like acceleration. Again, being familiar with this equation for the sake of this lesson is not important. What is important is we need to know what the units may be. So T represents time. And we understand that the unit of time is seconds. Acceleration in base units is meters per second square. Velocity is meters per second, and velocity again is meters per second. So if you deal with the equality sign and separate them on the basis of left-hand side and right-hand side, you will see that the unit on the left-hand side is meters per second. Okay, so now each unit on the right-hand side, the RHS should also be equal to the left-hand side, individually speaking. This plus sign actually divides U and AT into separate entities. Now, U will be dealt or observed separately. So this is meters per second, which is again equal, or the unit is exactly the same as the left-hand side. So this part is homogeneous, right? But when you separate using the plus sign, the A and T, now we have to make some calculations using the base units. So this is meters per second squared being multiplied by second. We realize that one of the seconds is going to get cancelled like this, and this becomes meters per second. Again, the AT part of the equation also gives us meters per second. So individually speaking, U was equal to the left-hand side and AT was also equal to left-hand side's unit, base unit. So now we can say that this equation is homogeneous, or you can say it follows the principles of homogeneity. Now let's look at an equation that may involve some other variables or some values, or let's say numbers. So again, this equation is a part of your course, but for the sake of this lesson, you're not required to understand what the equation represents. So V square equals to U square plus 2AS. Now this 2, since it's a constant, does not have a unit. We are going to ignore it, right? It will not participate in the homogeneity check. So on the left-hand side, we realize that we have meters per second being whole squared equals to, on the right-hand side, we have meters per second whole squared, again replacing their velocity units. And similarly, 2 will be ignored. Plus sign separates these two entities individually. And then we have acceleration, which is meters per second square. And then we have seconds, which is being multiplied like this, right? Okay. Sorry, S is basically time. Sorry, it's displacement. S is displacement. So that will be represented as meters. Now we can see that this becomes meter square divided by second square equals to meter square divided by second square plus meter square. Again, meter multiplied by meter gives me meter square, and second square actually already was present over there. So individually speaking, the unit of U is comparable or is equal to the left-hand side unit of V. And after multiplying and performing the algebra, again, we realize that this plus sign actually separates these two entities and they will be checked independently. And AS multiplication also gives us a comparable unit, which is meter square over second square. So again, this equation also stands to be homogeneous. Now we move towards questions, that what the question from the examiner are going to look like. So this is an MCQ. You'll find similar questions in P3 and P5 and in P2 as well. So no need to worry about this topic too much because it's easy, right? All right. So the first, read the question and try to solve this on your own. If you can, pause the video and see if it makes sense to you. So in this question, he says that we have a mass m, so the variable's unit will be kg. Then he says the spring constant is k, which means that the k is actually force per unit length. From Hooke's law, this is F equals to kx. So k will be equal to F over x, or extension, force represented by Newton divided by x represented by meters. Now for Newton, we know that F is equal to ma as a resultant force formula. So that will be kg dot acceleration will be meters per second square, which can be written down as kg ms minus 2, right? So replacing Newton with the kg ms minus 2 divided by m gives me mass cancels out, sorry, the length cancels out, so we are left with kg s minus 2. So this should be the base units of the spring constant. Then for mass, we have kilograms. He's asking us which equation out of these four options will represent the time period of the oscillating mass. Now we understand that the unit of time period should be seconds. So I need to have an equation or a setup in which I get the final unit to be seconds. Now, first of all, Do we need to worry about the variable 2 pi? No, it's a constant. We don't need to worry about that because it doesn't have a unit. So we can ignore 2 pi in all the systems, in all the equations, right? Then we come to the realization that if I want to manipulate kg s minus 2 and this kg of mass, because it's either k over m or it's either m over k in the given equations, right? If I want that, then I need to get rid of the kilogram. I need to get rid of kg, and I need to make sure that the second square becomes 1 second, because the time period's unit is just seconds, right? So something tells me, or again, it's by intuition, that mass or m should be divided by spring constant's unit, right? Why do I say that? Because we can see that the unit of mass is kg divided by the unit of, or the base units of spring constant are this kg s minus 2. So kg s minus 2, right? You could have done this the other way around. For example, k divided by m, and would have done the same thing, kg s minus 2 divided by kg. Even in this situation, you can see that kg or kg cancels out. But in m over k, we see that we get 1 over s minus 2, which if brought in the numerator becomes s squared. If we were to do this over here, we can see that s minus 2 becomes 1 over second square again. Now, if we have to get rid of this, can we leave the blank or can we leave it without an under root? No, we can't do that. So we have to choose an option that has an under root so that this square can be removed or this can be converted into a single power. So it should be either C or it should be either D, right? Okay. So by this time, I hope that you've already guessed it. It should be m over k. It should be m over k, right? Because only then we get an s with a positive power. And it should have an under root over itself so that it becomes s. So the closest possible option is going to be option D. That is how you use the homogeneity tool to solve questions, right? You may have a shortcut method to this. You may be able to solve this by ratio method. It's up to you. That is fine. I'm just here to explain what the concept of homogeneity expects from you, what it hopes to teach you. The next question is again fairly simple, but let's try to look at it. Now we have an under root, we have a power involved. All right, so he says there's a relationship between D and T given by this equation. Okay, fine. He says B and C are constants, so we don't need to worry about them. We may need to find their units, but let's see what they are. He says the unit of D is meter square, so let's replace them over here. 1 over T means this is 1 over S, which will be S minus 1. Equals to B is what we don't know because B is asked from us and C is being asked from us. So what they may be individually, this is what we're going to guess. So we don't know B, but D is meter square. So taking under root of this meter square, this leaves us with M, right? Plus C. Now we know that the plus sign or the minus sign is actually going to separate these terms individually so that they can be compared separately to the left-hand side. And if this equation is supposed to be homogeneous, then C should have the same unit as 1 over T. So if 1 over T is S minus 1, then C should also be S minus 1. So let's see which options represent that. So C with S minus 1 is option B and D, which means that option A and C will be cancelled out. I will not even look at them. I will not even check them. Now we have option B and D, right? We have to check either B and D. So what B is supposed to be? B should give me such a unit that after being multiplied or divided, it should again give me S minus 1, or it should give me 1 over S. By hook or by crook, I don't care. So B should be something that gets rid of this letter M, this length unit meters, and still give me a per second unit. So it could either be ms minus 1 or it could either be m minus 1, s minus 1, right? I'm going to try with ms minus 1 because that looks more plausible. So this becomes meters per second divided by meters. And yes, this successfully cancels out meters. And this becomes s minus 1. And again, this is 1 over s. So this also can be written as s minus 1 plus this c had to be individually s minus 1. Only then this equation will become homogeneous. So this option B is going to be the right answer for this question. Again, you may have a different technique. What you can do is, for example, for this one, what you can do is B divided by M equals to, it should be S minus 1. This is what it's supposed to be. You take m over there, so b's unit should be ms minus 1, and then you can come back to the same conclusion again, or recheck by putting this into the equation. It's your choice, completely your understanding how your teacher has taught you. That's completely fine. But again, we are supposed to learn what homogeneity tool teaches us. We can check any equation in the universe, be that proposed by any scientist or given by any physicist, by this homogeneity tool, and give this conclusion that yes, is this equation or does this equation fall under the influence or under the principles of homogeneity or not? This is our main concern, right? Okay,